Okay, so this is what we talked about yesterday. Factor the denominator, break it apart into however many factors that we have. You already wrote this down yesterday, right? There's a repeated factor. We have to include the lesser powers. If there's a quadratic factor, the numerator must be linear. Okay, that's what we went over yesterday. Now, we actually get to solve for A, B, C, D, blah, 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 blah. Okay? Number 15 is written on the board over here. Okay? What we're going to do is we're going to get rid of all of the denominators. We're just going to make it no longer fractions. So if we were to make this entire equation no fractions, what would we multiply by? Whatever your common denominator is, you're going to multiply both sides by it. That way, we cancel out all the denominators and we're just left with an equation with no fractions. Okay? So we're going to multiply by the common denominator. We're going to solve for our constants. Okay? One method that we're going to use, okay, is going to be to plug numbers in to make some of our factors disappear. Okay, so a strategy we're going to use would be to substitute in zeros, and I'll show you what that looks like. Okay, once you solve for A, B, C, etc., you must write the actual decomposition. Okay. Don't go through all the hard work of finding A, B, and C and then not actually write the fractions that should be added together to form your decomposition. Okay, so it looks like we're not 4 examples, and then you'll have some work time. All right, are you ready? Yes. You guys all look so excited. Okay. Does this one look familiar? I believe this is one we talked about yesterday, correct? Okay. Yesterday, what did we decide about the denominator? What did we take out of next? And then what can we factor that to? And then that factors to x plus 1 squared. Okay? So then we have 3 factors downstairs, so we're going to add 3 fractions together. So x plus 1, and x plus 1 squared is a repeated factor, so we have to account for both powers. All right. What are we going to put above a? I told you. What are we going to put above x? Above x plus 1 and above x plus 1 squared. C, it's a repeated linear factor. Okay, so now moving forward, we are going to multiply by the LCD. So whatever your denominator is over here, that's what you're going to multiply by. Okay, why? All right, so when we multiply this to this fraction, what happens? It completely cancels, and we're left with 5x squared plus 20x plus 6. All right, when we multiply it to a over x, the x's cancel, and we're left with a times plus. And x plus 1 cancels out, and we're left with b times
b times x times x.
we still have an x there, right? We have x and x plus 1. And then the x plus 1 squareds cancel out, and we're left with c times x. Okay, so now what we can do is we can strategically choose numbers to make some of our factors go away. So let's go back up to our denominator. What is something that makes this original denominator 0? Okay, so we'll start with 0. If x equals 0, when I plug 0 into this side, what happens? We get 6. If I plug 0 into here, we get a times a times 1. Plus, what happens here? We get b times 0 goes away. Plus c times 0. Well, that was convenient. There's our a. Okay, so now let's pick another nice number. Okay, if we plug in x as -1, what do we get over here? We get 5 times 1 minus 20 plus 6. What happens when we plug in -1 right here? Oh, that's nice. What happens when we plug in 0 or -1 right here? 0. And what happens when we plug it in right here? So you have 0 plus 0 plus -1 times c.
C equals 9.
So c equals 9. Okay. Now, since we have a repeated factor, we are out of numbers to make factors go away, but we still have to solve for b. Right? Is b the only one we have left? Okay, so what we can do is we can choose a nice number to plug in. What would be an easy number to plug in to where we can solve for our one variable that we have left?
1.
Sure. What happens when we plug in 1 over here? 5 plus 20 plus 6. What happens when we plug in 1 here?
40.
Here?
2.
Plus. But we know A and C, don't we? A is 6. And B is 9. Or excuse me, C is 9. So what is B? Okay. So now if we go back up to our decomposition up here, we know that our partial fraction decomposition is A over X plus B over X plus 1. Since B is negative, we can write -1 over X plus 1 plus C over X plus 1 squared. B is -1. And so instead of adding a negative, we can just make a subtraction. If you put plus -1 over X plus 1, I'm not going to count it wrong. It just looks nicer this way. Okay. Now, if we found a common denominator and added those together, then we would get back to 5x squared plus 20x plus 6 all over x times x plus 1 squared. That is what we just did. Let's try another easy one. Okay. First step, we're going to write this as x plus 8 over x plus 4 times x plus 2. So we have how many factors in the denominator? Two fractions. The denominators are x plus 4 and x plus 2. What goes in this numerator? Constant. What goes in this numerator? Excellent. All right, help me out. What's our next step? Multiply by that common denominator. So x plus 4 times x plus 2. Yes, you can think of it as over 1 if you need to, if that helps. So what happens to this fraction over here? Good. What happens to this fraction? The x plus 4's cancel and we are left with? And this fraction, multiply by the LCD and we're left with? Okay, now we get to strategically plug in some values. What would be a good value to plug in? We can plug in -2 because here we get 6. When we plug it in here, this factor goes to 0, so all of this goes away, and we're just left with b times 2, which means b is 3. Okay? Plugging in -2 makes a factor go to 0, and so you're only left with one variable to solve for. Okay? Another value? -4. When we plug -4 plus 8 is 4. When we plug -4 in here, we get a times -2. And when we plug -4 in here, it goes away. So what is a? -2. So our partial fraction decomposition is a over x plus 4 plus b over x plus 2.
Do we just show like all those steps, like what numbers we're plugging in and what the equation goes to?
Yes, I would like you to show me what numbers you're plugging in and at least this, so that way if you do make a mistake, I can help you find it. Okay? But we still did a lot of this in our head, right? If you need to write down more work, that is fine. I'm okay with that. But I know some of this you can do in your head. But like Tyler asked, I do need to see what number you're plugging in and how you're getting this number right here. All right. Let's try this one. Okay. So far, we've only seen examples with what kind of denominators? Linear. Okay. Things are going to change slightly when our denominator is not linear. What's our denominator? And x squared plus 4, can that be factored anymore? No. So we are going to decompose this into how many fractions? 2. What's our first denominator? And then x squared plus 4. What goes above x?
Okay.
What goes above x squared plus 4?
Bx plus c.
Bx plus c. X squared plus 4 is a true quadratic factor, and so we need a linear upstairs. Okay. Next step. Okay, so whatever, this is your common denominator every time. Okay? X times x squared plus 4 over 1, if you need it. So what happens when we multiply our common denominator to this fraction? What happens when you multiply it to a over x? What happens when you multiply a over x to the LCD? Plus, what happens when you multiply this one?
3x plus c.
Make sure bx plus c goes in parentheses because that whole thing is being multiplied to x. Now, we can plug in x is 0, and that would make this factor go away, and we could easily solve for a. But what's going to be the problem after we solve for a? Can I plug anything in here to make this go away? No. And even if we plug in a random number, like we did in that first example, if we know a and we plug in a random number, we're still going to not know 2 different variables. One equation with 2 variables, is that helpful? No. Okay? So another way we can look at these problems is that we have an equation, right? So what would happen if we multiply everything out on the right side? Let's do some distributing, okay? A times x squared plus 4 is ax squared plus 4a. Okay. And bx plus c times x would be bx squared plus cx. And we know that this needs to equal 3x squared plus 4x plus 4. So what we can do, we know that we have 2 equal equations, right? I'm going to go ahead and write this in a different order. I'm going to write ax squared plus bx squared plus cx plus 4a. Are you okay with me rearranging those? Are you okay with me rearranging those? Thank you. Okay? So this is what I notice. I notice that I have a 3x squared over here. So what does that mean about ax squared plus bx squared? That should equal 3x squared, right? If I have 2 equal quadratics, the coefficients of x squared should be the same, right? So what should a and b add up to? Here I have 4x. What does that mean about cx? C better be 4. Here my constant is 4. What is our constant on the right side? 4a, right? So that means our constant 4a better equal 4. So what's A? What's C?
4.
And if A is 1, what does that make B?
2.
Now we have A, B, and C. To write our partial fraction decomposition of 1 over the X. So A over X plus BX plus C over X squared plus C. Okay. Now I will tell you, the method we just used, it would work when you have linear factors, but plugging in numbers might be simpler, but you can use this method on any problem if you like it. Okay, or if you want to just remember one method, you know that this would work for all. Okay. All right, one more example, and then I'll give you a good solid 15 minutes of work time. It looks like you might get. Okay, so what is happening in the denominator?
Quadratic factor being repeated.
We have a quadratic factor being repeated. So here's our quadratic factor once, and then twice, and then what goes upstairs? AX plus B goes here, and CX plus D would have to go there. Okay. Now we multiply by x squared plus 2 squared. Whatever the LCD is, that's just going to be your original denominator. You're going to multiply the whole equation by. So when we multiply to the left side, we are left with when we multiply it to this first fraction, we have AX plus B times x squared plus 2, right? The second one, the cancels with the denominator, so we're just left with CX plus D. Anytime you have quadratic factors, there is not a real number to make those factors 0, so you have to compare coefficients, is what I'll call it. Okay? So if we're going to compare coefficients, what do we need to do on the right side? We need to distribute so then we can compare our coefficients. Okay? So we get first
AX.
outside,
2.
inside, last. Okay, so I'm just going to reorganize this, okay, because I want to write my x cubes first, and then my x squareds, and then I have plus 2ax plus cx, and then I'm going to write plus 2b plus d. All right, so, whoops. This is 8x cubed, right? Plus 13x. Okay, So our coefficient of x cubed is 8. So what is the same as 8 on the right side? A. Ooh, that's nice, isn't it? Okay. What's the coefficient of x squared?
0.
What are our x squareds on the right? And b. Ooh, look at that. Okay. What's our coefficient of x? 13. And what are our coefficients of x on the right side?
2a.
Okay, so we have 2ax plus cx. So we know that 2a plus c must equal 13. What is our constant on the left side? 0. What are our constants on the right side?
2b and d.
So 2b plus d better equal 0. Okay, well, lucky enough for us, we already know what a and b are, right? So if a is 8, then we can plug that in and help us find c. If a is 8, what is c? -3? All right, and 0 equals 2b plus d. If b is 0, what does that mean about d? Okay, so our partial fraction decomposition, ax plus b over, what was it, x squared plus 2? Plus cx plus d. Okay, and so since it's plus a negative 3x, we can just say minus 3x. Okay, so you'll have to be a little bit patient. Okay, there's a little bit more algebra involved, but nothing you cannot handle. Your homework is on page 506, so same page as yesterday. We have 17 through 29 by 3s, 27, 31, and 35. So I really like counting by 3s, but then I also really like 27, so if you need to like throw 27 in before you do 29, or if you are okay with out of order, just keep that in mind. And then 31 and 35. Okay, so you have 14 minutes. Let's get started.
Can I use the restroom, please?
Nice to meet you. 9, I need to science class. I love